Okay, so we were just talking about states of matter and how um, pure substances can only be separated by chemical methods. Mixtures can be separated by physical means. And it's really important we take a minute to try and define what that means. So we're going to try and distinguish between physical and chemical changes in this video. We're going to start with chemical and physical properties and then look at how those properties can be used to change matter. Physical properties are something that can be observed without changing the identity of the substance. So for example, here we have ice that's melting. It is still water, whether it is solid or liquid. It doesn't matter. So other examples of physical properties are these. Mass, you can step on a scale without changing your composition. The density, you can see if a penny is going to sink or float in water based on its density. It's still going to be a penny regardless of what happens. You can identify the color, the texture, see if something is magnetic, see if something is malleable, which means you can flatten it into a sheet, kind of with the mallet. You can see if it's ductile or try to pull it into a wire. Usually metals are both malleable and ductile. It's why they can be used for things like aluminum foil or copper wiring, that kind of thing. You can also determine where something freezes or melts. Like here, it's still water regardless of its changing state. Physical properties are what you're going to use to purify something. So you could use chromatography. You usually see chromatography in a lot of the police shows. They try and separate proteins or DNA or some kind of compound to identify somebody. You could also, you may have in school at some point done paper chromatography where you had something like black ink here. You know what, we have different colors. Might as well do it the real way. You had, you could put a piece of a dot on your paper and then you put it in a tub of water, and as the water goes up it pulls out the different components. So for example, your blue ink might be here, your red ink might travel way up here, and maybe something like your yellow ink here. All of these components go into this black ink. It's just that now they are separate, even though we didn't change them. Chromatography is can be used for gases, liquids. It's very useful. Distillation is how they separate the different components of petroleum, and so you can start to heat it up. As you heat up, gasoline or natural gas comes off. Then gasoline comes off at a higher temperature. Kerosene comes off even higher. Diesel oil, you have to heat it up even more, and so on. And so you can collect at this temperature for the gasoline. You can collect at this temperature for the kerosene, and so on. You can also use distillation to kind of purify things like water. Sublimation is used to change something from a gas into a solid, or solid to a gas. It is a solid to a gas is sublimation. Gas to a solid is deposition. It allows you to very quickly take two solids and have one of them basically vaporize. Solubility is another. If you have sand and salt and you want to separate those two components, you could mix it with water. The salt is going to dissolve, it leaves the sand behind. Physical changes are not going to alter what the compound actually is. You could cut it, you could melt it, you could freeze it, boil it, dissolving. All of these things still allow the substance themselves to remain the same. It's just that it's changed form. For example, this guy is going to take a gallium spoon, which melts at about room temperature, 85 or so, and it's going to change from a solid to a liquid. This is still gallium. It is just now in liquid form. It in no way has changed identity. If I were to cut a piece of paper, it is still paper. If you melt ice, it is still water. It has just changed form. So these are physical changes. Chemical properties you can only observe if you are going through a process changing the composition or the identity of the substance. So reacting, burning, oxidizing, these are things that allow you to change the substance. So for example, Titan, stop snoring, dude. Come on. If you burn a piece of wood, you can't get that wood back. You have changed it from wood to ash. Titan, go outside. If you react something, you're going to get a new substance. It's not going to be the same anymore. If you oxidize metal, it is now going to be rust. It is no longer the same metal that it was. It is now a new compound. Chemical change is going to alter the composition of the substance. Same three things really. Burning something, oxidizing it, reacting it. Those are what you get. So are these physical or chemical changes? You burn a log in the campfire. The question I usually ask is, can you get that back? Can you get that log back? No. So this has got to be a chemical change. Toasting marshmallow. You can no longer get that marshmallow back to its original uncooked state, so it must be chemical. If you dissolve sugar in your tea, is it still sugar? Of course. So it is a physical method. Boiling water. It's still water, regardless of whether it is a liquid or a vapor. So this is also a physical change. Cooking pasta. The pasta is cooked. That egg is never going to go back to its uncooked state. So it is a chemical method. And something floating around in water, it's just based on density, which means it is a physical method. And that is the end of this unit.